Good morning! Welcome to a video lesson in Statistics and Probability. I am Teacher Juliet G. Barnachea, your teacher for today's topic. Are you excited? I am just excited as you are. So let's begin. By the end of this video lesson, you will be able to illustrate a random variable as discrete and continuous, distinguish between a discrete and continuous random variable, and find the possible values of a random variable. So basically, our topic will focus on random variable. Before we start with our topic, let us have a simple drill. I want you to list the sample space of the following experiments. Number 1 experiment. List down the sample space of tossing a coin. The sample space of tossing a coin is a head and a tail. Second example is to find the sample space when rolling a die and tossing a coin simultaneously. So we have one head, one tail, two head, two tail, three head, three tail, four head, four tail, five head, five tail, six head, and six tail. Those are the sample space when we roll a die and tossing a coin simultaneously. Next experiment is drawing a spade from a deck of cards. Sample space are ace of spade, two of spade, three of spade, four of spade, five of spade, six of spade, seven of spade, eight of spade, nine of spade, 10 of spade, jack of spade, queen of spade, and king of spade. Number 4. Drawing a card greater than 7 from a deck of cards. The sample space are 8 of hearts up to king of hearts, 8 of diamonds up to king of diamonds, 8 of spade up to king of spade, and 8 of flowers up to king of flowers. So that is our drill. Let us now proceed to review. In review, we will find the probability of the following events. What is the probability of getting an even number in a single roll of a die? So if your answer is 3 over 6 or 1/2, you got it correct. Number 2, getting 2 heads when 2 coins are tossed. Sample space is head-head. The number of possible outcome is 4. So therefore, the probability is 1/4. Number 3, getting an odd number and a head when rolling a die. If you got it, 3 over 12 or 1/4, you are correct. Number 4, getting a 3 of diamond when a card is drawn from a deck of cards. If you answer it as 1 over 52 You are correct. 5. Getting a queen when a card is drawn from a deck of cards. If your answer is 4 over 52 or equal to 1 over 13, you got it correct. So that's our review. In the study of basic probability, you have discovered that an experiment is any movement that should be possible more than once under comparative condition. The arrangement of every possible outcomes of an experiment is what we call a sample space. You have additionally figured out how to mathematically list down the conceivable outcome of a given experiment. In tossing a coin, for example, the potential results are turning up a head or a tail. Let's do some experiment. How many heads when we toss 3 coins? Okay, so let us first list down all the possible outcomes. Possible outcomes are head, 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 tail, head, tail, head, tail, head, head, tail, 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 head, tail, and head, tail, tail. In this instance, there might be 0 head, 1 head, 2 heads, or 3 heads. Thus, the sample space is equal to 0, 1, 2, or 3. Then this time, the results or outcomes are not entirely equally likely. The 3 coins land in 8 possible ways. X is represented by the number of head, which we call the random variable. That particular example is a discrete variable. A discrete variable is a variable which can only be viewed a countable amount of values. Let's have example number 2. How many heads when we toss 2 coins? So here are the possible outcome. Head, 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 tail, tail, head, and tail, tail. Since we are talking about how many heads when we toss 2 coins, we will count the head in every outcome. In head, head, there are 2 heads. In head, tail, and tail, head, there is 1 head. And in tail, tail, there is no head. That's why it is 0. So the number of heads are 2, 1, and 0. The number of head is the random variable. This is again an example of a discrete variable. A discrete random variable is a variable whose value is obtained by counting. Examples of continuous random variable: height of students in class, weight of statistics books, time it takes to get to school, distance traveled between classes. A continuous variable is a variable that is being acquired by measuring. A random variable is a function that associates a real number to each element in the sample space. It is a variable whose value are determined by chance. In this manner, a random variable is a numerical amount that is derived from the results of an arbitrary trial or experiment. So we have 2 kinds of random variable. First is the discrete random variables. These are variables that can take on a finite number or countably infinite number of distinct values. These are the following: number of heads obtained when tossing a coin thrice, number of siblings a person has, the number of students in a classroom at a given time, and the number of dropouts in a school district for a period of 10 years. Second, and last example is the number of female athletes. Second type of random variable is the continuous random variable. A variable that can take an infinitely uncountable number of possible values, typically measurable quantities. So, continuous random variable represents measured data such as height, weights, and temperature. So, let's practice. I want you to get a pen and paper for you to write on your answer and check if you are correct. Classify each random variable as discrete or continuous random variable. Number 1. Score of a student in a quiz. If your answer is discrete random variable, then you are right. Number 2. The time a students eat breakfast. If you answer continuous random variable, yes, you are correct. Number 3. Time to finish running. If your answer is continuous random variable, yes, you got it right. 4. Amount of paint utilized in a building project. If your answer is continuous random variable, you made it right. 5. The number of deaths per year attributed to lung cancer. If your answer is discrete random variable, very good. 6. The speed of a car. If your answer is continuous random variable, yes, you are correct. 7. The number of voters favoring a candidate. If your answer is discrete random variable, yes, you are correct. Next, the time needed to finish the test. If your answer is continuous random variable, you got it right. Next, number 9, the number of eggs a hen lay. If you answered discrete random variable, then you are correct. Last number, the average temperature in Baguio City for the past 5 days. If your answer is continuous random variable, you got it correct. So, in this activity, you're able to identify and distinguish what a discrete random variable and continuous random variable. So let's continue. Let us have finding the possible value of a random variable. Suppose 2 iPhones are tested at random. We want to find out the number of defective iPhone. Thus, to each outcome in the sample space, we will assign a value. These are 0, 1, or 2. If there is no defective iPhone, we assign the number 0. If there is one defective iPhone, we assign the number 1. And 2, if there are 2 defective iPhone. The number of defective iPhone is a random variable. The possible values of this random variable are 0, 1, and 2. Let us read and analyze the given situation below. Let D represent the defective iPhone and N for the non-defective iPhone. If we let Y be the random variable representing the number of defective iPhone, show the values of the random variable Y. Complete the table below to show the values of the random variable. So, in finding the value of the random variable Y, we have 2 steps to follow. First, we will have to find the possible outcome, and then from the possible outcome, we will have the value of the random variable Y by counting the number of defective iPhone. So, first possible outcome will be defective. How many defective do we have in this outcome? So therefore, there are 2. Another possible values as I draw 2 defective iPhone is defective, non-defective. In this possible outcome, you have 1 defective iPhone. Next possible outcome is non-defective, defective. And here again, we have 1 defective. And lastly, possible outcome is non-defective and non-defective. In this case, there is no defective iPhone, so therefore, the value is 0. To summarize, the value of the random variable Y, the values of the random variable Y are 0, 1, and 2. Let's have next. Suppose 2 coins are tossed. Let C be the random variable representing the number of heads that occur. Find the values of the random variable Z. This time, the random variable is the number of heads. And number of heads is represented by capital Z. So steps. Determine the sample space. Let H represent head and T for tail. The sample space for these experiments are the following: tail, tail, head, head, tail. Second, we will now count the number of heads in each outcome in the sample space and assign this number to this outcome. So it goes this way. Possible outcome and the value of the random variable Z. Z is the number of head. So in head, there are 2. In head tail, we have 1. In tail, we have 0. And tail head, we have 1. So therefore, the possible values of the random variable Z are 0, 1, and 2. That's it. So we will now proceed to activity to check if you understand the discussion. Again, I want you to get a pen and a paper. Identify whether the given experiment involves a discrete random variable or a continuous random variable. Write D for discrete and C for continuous. Getting the temperature of patient admitted in a hospital. If your answer is continuous, you are correct. Collecting data about the weights of students in a certain school. If your answer is continuous, that is right. The number of patients admitted in the hospital due to COVID-19. If your answer is discrete or D, you are correct. The number of no work, no pay in a certain municipality caused by the pandemic. If your answer is discrete or D, you are correct. Next is the number of families that are members of Poor Peace in Quezon. If your answer is discrete, you got it right. Number 6, in a box of 2 balls, one white and one yellow, 2 balls are picked one at a time with replacement. Let X be the random variable representing the number of white balls. Find the values of the random variable X. So here is the answer. The possible outcomes are white, white. Since the random variable pertains to the number of white balls, the value here is 2. In white, yellow, and yellow, white, the value of the random variable or the number of white ball is 1. In the next outcome, yellow, yellow, there is no white ball, so the value of the random variable is 0. To summarize, the value of the random variable X are 0, 1, and 2. That would be all for today.